Hello, I am Bob Coker, Chief Operating Officer for Rimkus Consulting Group. Rimkus Consulting Group and Rimkus Analytics, a wholly owned subsidiary of Rimkus Consulting Group, provides multidisciplinary forensic engineering and financial advisory services for corporations, attorneys, and insurance companies. This video presentation discusses equipment used to measure the slip resistance of bathing surfaces. So how did it come about that we needed to measure the slip resistance of a bathing surface? One study reported that slips, trips, and falls comprise 42% of injuries suffered by hotel guests. One component of slips, trips, and falls are falls within bathrooms and more specifically in areas used for bathing. As you can imagine, falls in bathtubs and showers can result in serious injuries. These accidents are more frequent than one may think and potentially very severe due to the hard nature of the built environment of the bathing facilities. By the mid-1970s, the Consumer Product Safety Commission had determined that bathing facilities were hazardous structures. The National Electronic Injury Surveillance System, which is a national database of injuries registered at hospital emergency rooms, helped to identify and quantify the relative severity and frequency of bathing facility accidents. Slip and fall accidents were the most frequent type of bathing facility accident. As part of the Consumer Product Safety Commission initiatives to address bathing facility safety, the American Society for Testing and Materials, which is commonly known as ASTM, formed a task group on the safety standards for bathtub and shower structures. That task group developed the standard ASTM F462 titled Standard Consumer Safety Specification for Slip-Resistant Bathing Facilities and was the first issued in 1979. The intent of the standard is to reduce accidents that may in some way be due to the slip resistance of bathing facility floors. The ASTM standard specifically addresses slip-resistant requirements for bathing facility floors. The standard provides a specific slip test device, a test procedure for making such measurements, and minimum performance requirements for a bathing facility to be considered slip-resistant. The device that meets the requirements of this standard for measuring the slip resistance of a bathing surface is the Brungraber Mark I, which is the device we will be discussing today. At the heart of F462 is the Brungraber Mark I. The Brungraber Mark I is a turbometer or slip meter originally developed for more traditional slip-resistant measurements on walking surfaces. The Brungraber was developed by Dr. Robert Brungraber, who was with the National Bureau of Standards at the time. The Brungraber was one of the first portable articulated strut devices for slip-resistant measurements. The articulated strut technology remains the basis for some of the more commonly accepted slip-resistant measurement devices used today. The Brungraber Mark I is by today's standards a very simple device. The device's simplicity being one of the reasons it was chosen for the F462 standard. There are no batteries, no digital readout, and no computer. The device consists of an approximate 10-pound weight that applies force through an articulated strut to a test foot. As the device is operated, the test foot, which is in contact with the surface being tested, begins to feel the additional force as the weight is lowered. Eventually, the force is great enough that the foot slips on the surface. When the test foot slips, a braking mechanism is activated that stops further travel of the recording rod. The reading on the recording rod at the point of the slip, read in inches, is a measure of how far the weight traveled, which is directly related to the amount of incline of the articulated strut and the slip resistance of the surface, commonly called the slip resistance index. We will quickly demonstrate the basic procedure for using the Brungraber Mark I for testing a bathing surface. In this example, we will use the Brungraber Mark I to test the slip resistance of a bathtub. First, the bathtub surface is wiped down with alcohol to remove any contaminants. The slip resistance is measured in 9 different spots on the bathing surface, so tape is utilized to help us determine the 9 different locations the Brungraber Mark I will be positioned for testing. A soapy solution comprising of 4 parts distilled water and 1 part soap solution is placed into the tub. The temperature of the water and the air is measured and recorded. A piece of glass is placed into the soapy solution. This piece of glass is used to establish a baseline which the measurements on the tub surface will be compared against. Basically, we are comparing how slippery the tub surface is compared to a piece of glass. We take a total of 6 measurements on the glass and record the results. The glass is then removed from the soapy solution and the Brungraber is positioned at one of the 9 marked positions in the tub. A total of 2 tests are conducted at each of the 9 locations and the results recorded. Once we complete the measurements at 9 different locations, the Brungraber Mark I is removed from the bathtub and the piece of glass reinserted into the tub. The Brungraber Mark I is placed on the glass once again and 6 more baseline measurements are recorded. I won't bore you with the details of how the mathematics are completed, but the recorded measurements are utilized to calculate the slip resistance index at each of the 9 locations. A passing slip resistant index of 0.04 or greater is required to be considered slip resistant. If any of the 9 locations has a slip resistant index below 0.04, the bathing surface is not considered slip resistant. As part of our premises liability services, we are actively engaged in performing bathtub and shower slip resistant measurements. ASTM F462 is a standard by which we can utilize the Brungraber Mark I to determine if a bathing surface conforms to the standard. This educational video was prepared as an abbreviated overview of the Brungraber Mark I tribometer and the associated ASTM 462 test method for bathing facility slip resistant measurement. This video is a brief, informative overview and does not include all aspects of the Brungraber Mark I tribometer design, maintenance, calibration, or operation. We hope you have found this video informative. Thank you.